Forward. Okey-doke. So thank you everybody for coming. Okay. My name is Nathaniel Elliott. I'm going to talk to you a bit about Hashistack, Kubernetes, and creative destruction. So here's the deal. I've only got about one good why Kubernetes talk before the market completely saturates. This is that talk. I'll try and keep it minimally technical. Like most presentations, it's semi-autobiographical. I'll try and keep that at least minimally relevant. Like a lot of what I write, this is going to end up making some impolite commentary about some good people's good work. We are well behind. Sorry. So when I say we are monkeying it, he's actually at the dial. So should I be like ticking you? Okay, sorry. So about 4 points in. Okay. This is going to make some impolite commentary about some good people's good work. I'm going to try and front load it with my failures so you can take my trash talking with plenty of salt. So ancient history. Started programming when I was 14, and when I was 15, I was literally hired off the streets to program for money, which set some unrealistic expectations about how easy it would be to get future work. Especially because I got into web dev right around 2000 when the bubble burst. My apologies for the profanity, but it won't improve. So skipping ahead, we're going to skip over some PHP horror stories, how I found DevOps at National Instruments, and Iron Fan and CloudFormation Ruby DSL, which I was involved in open sourcing. What I'm really good at is using open source software and Google. I'm also really good at picking losers. An early example, around the time I left work at National Instruments, I decided that what the world needed was high availability LAMP. I was going to call it CLAMP. I'm not very good at marketing. I now have a marketing person to help me with this. Obviously, it didn't get as much uptake. It was 20 different things bolted together, and not all of them really well tested. Iron Fan was the next major thing I dealt with, and I got several good years at InfoChimps before they downsized and sold to CSC. And unfortunately, when they went to CSC, CSC is a puppet shop, so they basically abandoned Iron Fan. Now, I, for a time, was thinking I was going to carry the flag forward. I'm very familiar with it, and I'd gotten really good at it, and I was known for doing it. So I had some connections for helping out, hoping to help out. Turns out, without another company behind it, a freelancer on an open source project, it's not terribly appealing. Fuck. So I took a job at Bazaar Voice. And after some initial work there on other projects, I reached the realization that configuration management was not really the best way to be approaching this type of problem. In a lot of cases, container orchestration is better. So I once had a much longer presentation, involved a nasty barnyard analogy. Be glad I'm not doing that one. Configuration management is ultimately a halfway step. It replicates old school ops practices technically. So it's very focused on the machine as the core object that you are maintaining. It produces a fairly high level of centralization. Chef, for instance, every Chef run couples every configuration part to every other part, or at least it used to. I expect it's moved past that now, but even now, it's still a central point of failure for a lot of architecture. Container orchestration decouples a lot of the application layer concerns from the machine layer concerns, which makes it a lot easier to handle on both ends. So At Bazaar Voice, the tool I picked for it was Flynn. Flynn is a full stack container orchestration system, provides a Heroku-like interface and also a Docker interface. Picked it for a couple of reasons. First of all, it is a single binary. This was a small team I was on. I wasn't sure that we were going to have a lot of manpower behind it. So being a thing that deploys a single binary rather than a full stack of things at the time was a very good idea. We're British, so scale it down a bit. I knew I had to produce results fairly quickly if I wanted buy-in. So I could not be experimenting with huge frameworks. I had to pick one that was small enough for a single person to get something in several months. Ultimately, however, Flynn is too full stack for its own good. It doesn't play well with other ecosystems, and it's too small to compete with them. So as I left Bazaar Voice and struck out on my own, I first tried to start replicating a lot of the work I did with Flynn in Terraform, because internally to Bazaar Voice, I had been using CloudFormation. That was their tool of choice. And I don't like the vendor lock-in CloudFormation causes. So I tried to replicate that in Terraform. And that got me to looking at a bunch of the Hashistack folks' stuff, and I started to realize how far ahead their ecosystem was. Ultimately, also ran into some non-standard deploy issues playing around with the Hashistack. There's a lot of good stuff, but it's mostly Docker Swarm targeted, or more recently, Kubernetes. And in case any of you missed it, Kubernetes has won. Fuck. So, time to retool yet again. So why am I bragging on this? They were all the right choice in context. They were all good tools. They all did what we needed them to do. They didn't reach as far as I had hoped the tool could reach, but for where they are, they were good. Changing your mind in technology is a virtue. It's not a vice. A lot of people get locked into their tools and cause themselves and other people around them pain. Every failure was a guidepost. The failings of Iron Fan helped point me towards what I needed from container orchestration. The failings of Flynn made me willing to see the value of a much heavier stack. And that's kind of what it feels like to be ahead of the curve. You're going to pick a lot of things that end up being losers. If you're trying to do advanced stuff, you're taking gambles, and those gambles aren't going to always pan out. And a lot of the times it's for environmental reasons, not because of you. I would have loved to see Flynn win, but it's not going to. And the closer you get to the breaking wave, the more you're going to have to cuss and reorient. You make a mistake, you keep on moving. So Terraform. Terraform is infrastructure as a service provider abstraction. I can more or less provider abstraction. It's a very leaky abstraction. Ultimately, you have to still know the underlying providers, but you're using one tool set to orchestrate across many different clouds, which means that you can get a pretty reliable layer of compute under what you want to do. It's about it, but it's enough. Kubernetes. You get high availability and high efficiency architecture out of the box. A large argument for container orchestration is that it slices a machine thin. You're not wasting a lot of CPU to produce one small service that sits there and responds to one request every 5 minutes. And if you think I'm joking about that, I would like a guess as to the average percentage of CPU usage in machines I was going to replace with Flynn at Bazaar Voice. Hands up. You are very optimistic. Goose egg. When you run an entire EC2 instance to support a single service, which you happen to do a lot in naive microservices environments, your costs quickly outscope your actual use. So Kubernetes also gives you amenities, the ability to provide common tooling to your developers that requires little or nothing for them to use. A good example of this is the ingress, which gives you routing from a common IP address, all sorts of control over that routing, and you don't really have to do a lot of development of things. You just have to push a little YAML. The airplane rule. The core tools should work the same on your laptop as they do in the cloud. This was something from Flip Cromer over at InfoChimps. We never got there at InfoChimps, and I was always a little sad about that. Minikube is available out of the box. Kubernetes is now embedded in Docker and several other things. So you have an opportunity to push the same code you would be pushing to production to your local machine and see how it works there. And packaging. Ultimately, packaging is about combining up abstractions into an easy-to-handle thing. With Helm, I was able to go from zero experience with Kubernetes to a fully functional load-balanced WordPress deploy in 2 normal working days. And I wasn't pushing it. I was also surfing Reddit. So what all that gives me together. First of all, let me introduce Clem. No. But it does let you do this. So you can support a wide array of existing architectures inside Kubernetes. It's not the most advised route, but if you're still working in a colo and you want to push people to the cloud, you can take stateful stuff that's in a colo and migrate it into Kubernetes. It's not just push button, but it's not impossible either. It gives me a predictable shared build architecture. Everybody builds into a Docker container. Those Docker containers are decorated with Helm package. All of that is pretty easily readable. All of that is pretty easily writable. A standard to develop against. Up until this point, it's been anybody's business. Like Docker was kind of a standard, but how you put Docker things out there was all over the map. Now there is a clear front runner. I'm sorry to everybody who worked on the other ones, but network effects are going to get you. And most of all, it's a tool I can just use with less glue code than before. And since a good 80% of my job is actually writing glue code, that's actually significant. Okay, so rebuild from scratch. I had a old boss who once, after a rather hairy ops experience, told me backups don't matter, restores do. So rebuilds are restores for architecture. If you can't rebuild it from scratch, are you really sure that you have that architecture, or are you just kind of hopeful that it's still existing? So why do I keep throwing tools away? First of all, code is a liability. I'm so glad Charity Majors said this. She is way more popular than I am. And so if she can say it, I can probably get away with quoting her. Code really is a liability. The more code you have, the more code you have to maintain, the more eyeballs have to be paying attention to it, the more tests you have to run. Every time you have extra code that doesn't support your immediate needs, you're less efficient than you could be. Every line of code you maintain weighs you down. So stop maintaining code that isn't core to your business. Stop maintaining that crazy CI architecture that's built out of 5 different things that aren't standard. And celebrate every time you get to throw away custom code in favor of standard tools. One of my favorite things as an ops guy is shutting things down, because that's the hardest thing you can do in your job. Spinning things up, that's easy. But convincing a business to stop doing something they had been doing, that's difficult. And that's going to be a lot of y'all's job if you want to use Kubernetes, because it's going to replace a lot of things you do now if it's going to be most effective. Thank you. I know that was less technical and more philosophical. I'm open to some technical questions as well. I apologize for making you type out the hash. I really wish I had a little bit more prep time in this so that I could give you a nice URL there at the end. I will make sure that it gets posted to the list as well, so you don't have to camera and type out. Questions?
Yeah. So in this pattern, where do you draw a line between management and
So the question was, where is the line between image management and config management?
I think it's like a preference. Right?
It really, it is a preference and it is a moving line. And part of the joy of having an architecture you can rebuild parts from quickly is that you can move that line later. So pick the one that is the easiest. I don't have a good reference for it right off the top of my head, but I read an article recently that kind of showed the cycle you go through with hard coding, configuring, DSL, etc. Sometimes hard coding it is the best. I know that's a heretical thing to say, but if I'm throwing it out in a week, why not hard code it now? And if I don't know which way I want to abstract the configuration yet, why not hard code it until I've had a better chance to figure it out? So you get to delay a lot of choices till a more appropriate time, and then the answer should be really easy to decide.
Examples in your production service that any users were using, but who said utilization, entire reason to instance. Like, what is the political procedure right that is in place to make turn something off?
So at Bazaar Voice, teams were managing their own costs largely. So it was a fairly easy thing to say, hey, you see these 5 services that are running that are not essential necessarily, but you can't turn off yourself. Let's move these into this core thing, and you won't have to pay as much. You won't have to complain. You won't have your supervisors breathing down your neck. For actually turning whole things off, which is a slightly different question, you need to have people in the business value chain who can prove that it's less value than it is cost. That's what happened at InfoChimps with its big API. It was a very well architected thing, and ultimately we weren't getting traction, and we were on other things. So. I'll be honest, I'm not certain. There is going to be a long tail of migration problems where configuration management is an easier sell than container orchestration. Like, container orchestration is a larger problem to wrap your head around. It works on applications differently. You start thinking a lot more lean in the application itself and a lot more about decomposing into the architecture. Not every company is going to be ready for that, and not every company really needs to. There will be certain companies that get as much tech as they need out of this older way, and for as long as that company's tech is running, it will do just fine. So I don't see them going away. I do see them losing mind share as in fresh projects as time goes on.
Do you see there being like a minimum number of apps maybe you should consider having to get into, like, or is like 2 apps?
I would say even a single app is enough if you're trying to experiment. So for it to be a stable setup, you want at least 3 nodes. You want them to not be tiny nodes. So you should have projects at least equivalent to that in price that you're looking to put on the axe if you want to make the price point comparison. But really, The hardware cost thing is almost a dodge because hardware costs are fixed and going down for the most part. Like they go up a little bit with scale, and they will, but so does income with scale. So that's kind of a wash. Software developer costs are crazy through the roof. Every one of us costs the company like 200K fully loaded. Saving minutes of our time across the company is a far bigger savings. It's just much harder to track. So I would say you don't need a minimum. You're gonna find savings as you go along all over the map. And there's also 3-4 major providers now that have an Kubernetes implementation themselves. Google Cloud Engine is kind of the gold standard because Google developed this. Azure has one, AWS has one, and I'm forgetting who the fourth is. Yeah, I mean, at this point, it's more a question of whether they're a major one at this point. There's a million minor supporters of Kubernetes all over the place. So you really have options for how you choose to use Kubernetes. And yeah, start on your laptop. Minikube works just fine.
Give some examples of what those things are.
Well, unfortunately, a lot of them are the configuration management ones. A lot of companies are used enough to configuration management that they're going to put it into their build for their Docker container. And that can work, but realistically, if you're doing it right, your Docker container should be a single app. It should not be so complicated that a bash script won't work. And a bash script is ultimately a lot less infrastructure to worry about the attack surface on, all sorts of other things that continuing to carry the old code in won't be. Like I have worked a lot with Puppet and Chef and I like them, but I have intentionally chosen to not use them in any of the builds of container orchestration that I've done.
On your host machines, are there any things you like to add, maybe enhance the experience with Kubernetes, or is there anything that comes with like using Kubernetes that you need to, or as a requirement?
Some good first starts. Helm, you got to install Tiller. Good for pushing packages up there. Get the Nginx ingress controller working, and start just parceling out subdomains from a common IP address and a common domain. Beyond that, it really depends on where you're deployed. Google Cloud Engine has stable backend drives for the persistent sets, so you can just rely on those. But if you're going in a less advanced deploy, you may have to put Ceph in for those, that kind of thing. Ultimately, it depends on what you're trying to do with it.
One really good thing is showing this has all also that way just learning about learning new tools and stuff. That's cool.
Google Cloud Engine also gives you like $300 in credit to try things out, and that'll run, especially if you put it on, I'm spacing it on the name of the mode, but basically their spot pricing is instead, I can turn this off at any time. Yeah, preemptible instances. If you put them on preemptible instances, you're paying about a quarter as much, and you're getting a free Chaos Monkey exercise of your architecture. 3 is kind of a good minimum because you want quorum. Otherwise, I mean, you could run kube on a single VM, but why? It only provides so much on top of a single. Anyone else? Yeah.
Yes, you talked a little bit about Terraform learning sections and Terraform.
Absolutely.
Two different problems.
Yeah, Terraform is how I get Kubernetes where I want it. And it also, there are things that Kubernetes won't handle by itself that you'll want. External DNS, for instance. And yeah, the Terraform for setting up a Google Cloud Engine is maybe half a page. So it's pretty lightweight, but it's does a lot of heavy lifting.
Do you use Terraform?
For in that example, yeah, you can do both, and the latter is part of why I'm sticking to Terraform rather than more Google Cloud Engine specific tooling.
Is there anything used like Terraform?
Yeah, though a lot of the things that leap immediately to mind actually use Terraform under the hood. Cops, that was the one. Yeah, which is Terraform under the hood. It isn't? Then I'm thinking of a. Oh, okay. Yes, you're correct. That is correct. I looked at Cops. It is another way to go, and it may ultimately be the way I end up going. Right now, Google Cloud Engine. I don't want to pick up a heavyweight tool when I can use a lightweight tool. Is really where it comes in. I haven't investigated it terribly closely. Yep. Right, but once you've got the infrastructure set up, that helps deliver on some of the promise of Kubernetes to have a very automated infrastructure. Yeah, among other things.
So Kubernetes runs all the things, but what do you do to manage the types?
So there are several options. First thing I would highly recommend is if you're going to be doing a live upgrade, that you have some staging environments to test those live upgrades. You can live upgrade a cluster. I'll be honest, I don't have a tooling recommendation for you, but I believe it is possible to connect two separately constructed clusters and migrate between them. I would have to go searching for the name of the tooling. And generally, sorry, do you? Okay, so COPS is one way to accomplish this. Thank you. Let's see.
So alongside Kubernetes, on the registry.
You've got a lot of options. I don't have a specific recommendation because it really comes down to what your environment is trying to do. If you're security focused, you're going to want to bring that internal. If you're doing open source stuff, you're probably okay to use a large amount of existing infrastructure for it. If you're bringing it internal, I would recommend possibly putting it in its own small Kubernetes cluster and maintaining that on a separate life cycle from other things. That does provide some bootstrapping issues, but you can blue-green that so that it's not terrible. Any other questions?
You talked about like having service running on I'm not exactly sure what things you run on Kubernetes, but in the I need to make, I mean, I don't actually know since other stuff. Do you have any idea what kind of savings?
That's another very fuzzy contextual question. So from the similar problem at Bazaar Voice, the bounding factor was not CPU ultimately. These were a lot of low usage services, so most of their resource was in memory. If you're on EC2, because of the way sizing works, and this is probably true of other platforms, across a large enough sample, you will be using roughly 50% of your memory. And that's because every time you start to hit memory pressure, you double your instance size in most use cases. So just being able to slice it thinner and getting up to, say, 80% memory usage should save you that interval, whatever that interval is, across the things you are bringing into it. The problem with making a price-based argument is that there are more fuzzy things in the price-based argument than there are certain things. And the fuzzy things are the ones that we actually care about more. Developer experience, ability to recover quickly, that kind of stuff. We can make those arguments, but they are harder to tie to dollars. More questions?
Well, it's certainly important to get. In the end, how do you go
Yeah.
innovation cycle?
Yep.
Where are we seeing the acceleration?
I can go from no Kubernetes to a fully functioning cluster in roughly 5 to 7 minutes. I can go from no application to fully running application on a LAMP stack, or well, LAMP, in 2 minutes or less. So I can break things all day long and not care. And I do. That's my development cycle now is, I wonder if this will break things. Oh, it broke things. Okay, now I know more. And that is so refreshing compared with the hold your breath and wait 30 minutes for the whole build to happen. And yeah, it frees you from a lot of the more tedious parts of development and maintenance. Like trying to determine whether this one-off issue is a continuing issue. Now you don't have to immediately diagnose. You can, with the right kind of architecture, you can just spin up its replacement, pull the thing that was working poorly out into a sidelong thing, examine it at leisure, tear it down when you're done, and not be doing this at 4 in the morning on a weekend while your kid's crying. You can do it 9 a.m. the following morning, having put out the fire. And I'll be honest, it's reduced my urge to chase down tiny bugs right away. Because if a tiny bug is not causing a huge problem, I can actually now prioritize and just work around it a lot of the time. It's not the best thing, but having that flexibility is often really useful.
So, I don't know what you developer adoption.
Well, I've got a consulting firm, so I get to tell them what they use. So I'm probably not a good choice there. I will say that the relative size of crowds I have heard talking about Flynn, the Hashistack, and Kubernetes have been each an order of magnitude larger than the last. I have no doubt in my mind that Kubernetes has the environment that's network, the community that is going to mean that it is the winner long term.
So, back in the day, this is amazing. Kubernetes to me is seen much overly complex because it solves all of the brings with it, and then I've always avoided it for simpler. Do you find as you're going on learning curve?
A learning curve is always going to be an impediment. I don't think it's a terribly steep learning curve. If you know how to chef, if you know how to run Linux, not much about how you interact with this will be novel at all. It's a really large, complex Linux service with a local sidecar app that lets you reach into and manipulate its API. It speaks mostly YAML, which is ugly but workable. Helm packages let you template that out and kind of abstract away from a lot of its complexity. It does have some sharp edges, I'm not going to lie. I've cut myself on it several times this week. But so does everything else in this field. Like every other container orchestrator is at least this bad or worse. And it's going to get better, and it's going to get better a lot quicker than other ones because it's now got so many people behind it that everybody's jumping on it.
I mean, more of a developer than an ops guy. And so far, only thing that serverless couldn't do for me is run proxies. So to run proxies, I launch instances. That's why I have extra complexity. For everything else, my default go-to is serverless. So what did serverless not do that would make you take on the complexity of
Move providers. Unless you're deploying the serverless platform yourself, you are tied to whichever provider you have chosen. Which is not necessarily a huge downside. And if you like serverless, I'm not going to say it's the wrong way to approach it. What I think is going to happen under the hood is developer experience on Kubernetes is going to slide more and more towards serverless styles. To the extent that it doesn't already, like there are several serverless platforms built on top of Kubernetes. And yeah, if you like that level of abstraction, by all means, go to that depth. That's kind of the extreme end of what I was talking about with amenities, where most of the surrounding problem is being handled by the architecture, the logging, the metrics, the routing, etc. And you're just handling that core business logic. That's one of the ways that things will continue to go, I think.
I'm on the main execution engine. The Kubernetes looks like stuff. Usually it's because it's a tutorial on the other one, so
It's almost certainly network effect first, regardless of the technical superiority. Like, I don't want to get into a Betamax VHS argument, but ultimately, VHS won for business reasons. Kubernetes is winning for business reasons. That's nothing against its architecture. I quite enjoy everything I see in it, with the exception of YAML, just because YAML. But it seems to be written by a really smart group of folks over at Google. Many different platforms have now standardized against it. So even if at one point the code was less compelling, it's now compelling because of the network effects, because so many eyes are going to be on it, buffing out those sharp edges and whatnot. Any further questions?
What do you write for 15?
There was a local programmer who had a document or a sticker printer written in C, and he was rewriting it in C++, and one of his things had this weird bug in it. And he hired me to be a little Dutch boy on that bit of code while he was doing the other thing. No, I read a C++, or no, it wasn't plus plus. It was just a C book. I read a C book about a particular thing that apparently the guy who wrote this function had not. It was genuine newbie luck. Thank you all very much. Feel free to come bug me. If you're looking for folks to help you get into Kubernetes, that's what we do. If you're looking to work for a firm that's all in on Kubernetes, that's what we do. Come talk to me.
Thanks.
Thank you.
So it turns out there's a guy here in the audience that knows the architecture of Kubernetes and how it's all put together and why, and he's offered to whiteboard